Hello, welcome to everybody from the forest. Good to see you all again, though I'm not actually seeing you. I am here in our classroom with my video assistant production team. Say hi, video assistant production team.
Hello, my name is Kira Rose Vickers, and I'm very delighted to be here today, I think.
Okay.
Hi, Nicole. Amos.
Right, and we are here to talk about the phases of matter, in particular focusing on the liquid and solid phases since we finished our study of gases. Quick review of the big ideas of the three phases. Solids, of course, have the properties that they are in a definite shape. An interesting one there, and a definite volume, so that doesn't change. Liquids, of course, have a definite volume, doesn't change when we change the container, but the shape changes. So the liquid takes the shape of its container. And that's not a big enough container for all that liquid, so I'll put that back in there. And then finally, gases have no definite shape or volume. They simply fill their containers, and so I'm going to fill a container with some gas right here. Okay, video assistant production team. All right, so have a sample of gas right here, and we are going to consider right now what makes things be in the liquid phase or the solid phase sometimes. Why isn't just everything a gas? In order to understand that, let's consider two familiar substances. One of them I've collected in this balloon. Okay, here you go. Yay. I'll give you a chance to pause the video for a minute and see if you can think of what's in the balloon. That was just compressed air that I filled it with, so you should be able to name the two major things that are in the balloon there. Okay, throw it to Amos. Throw it to Amos. You can throw it to Amos. All right, throw it back, Amos. I need that balloon again. Thank you. Okay, so hopefully now you have unpaused the video, and I'm going to tell you that this has in it primarily nitrogen and oxygen. You knew that. So let's consider why nitrogen and oxygen. Let's just focus on the nitrogen for now, since it's mostly nitrogen. Why nitrogen is a gas, whereas this water is a liquid. What makes it do that? So a lot of times when I have people think about that, people will say, well, it's gravity that's pulling those liquid water molecules down and keeping them in the bottom of the beaker there. But gravity, of course, is also acting on the molecules in this balloon, and yet they're going all throughout. And furthermore, if you think about those things, nitrogen into water, H2O, if we consider the weight of those molecules, nitrogen molecules have a weight of 28. Water molecules a weight of only 18. So these are actually lighter molecules, and yet there they are all clumped together at the bottom of the beaker rather than spreading out and filling the room like these nitrogen molecules do. So what is it about the nitrogen molecules that spreads them out, the water molecules that keeps them together? You might think it's something just inherent to the molecules. The nitrogen molecules have to be spread out like this all the time. Water molecules have to be clumped together. But if you think a little bit more about that, we know that's not the case. I could get these water molecules to become a gas. Easy enough. Put it on here, turn that on, heat it up. The water boils. You know that. We're not going to do that. So also, and you may not have seen this before, nitrogen. We could get this nitrogen to exist in the liquid phase. Well, not this nitrogen, but some other nitrogen that I brought with me. You probably have seen this before, may not have seen this before, but I have right here a container, and in this container is some nitrogen that is liquid. All right, so come on up close for the video on this. And you can show right in the container. You can get a little bit closer. All right, so there's our liquid nitrogen. So nothing about nitrogen itself that requires it to be a gas. So while we have the liquid nitrogen out, I'm going to do something fun with it just because it's fun to play with the liquid nitrogen. One thing that we can do with the liquid nitrogen, of course, we know in order for the nitrogen to be a liquid, it has to be really, really cold. The liquid nitrogen is, oh wow, I don't remember now off the top of my head the temperature of that, but I think it's around -200 or so degrees Celsius. I believe that's the case. Right around there is the condensation point at which nitrogen condenses. And so here, ordinary racquetball, put the ordinary racquetball into the liquid nitrogen, and there we go. You can see it bubbling up there. So the nitrogen is boiling now because the racquetball is so hot in comparison to it that it's warming up that nitrogen and getting it to boil. But as the racquetball spends some time in there, the rate of boiling slows down as the racquetball cools down. And in just a moment here, we'll pull this thing out. And so we made that racquetball nice and hard. All right, so I'm gonna put it back in there for a moment again to cool it down one more time.